case study. I was asked to pick a topic which is interesting and which actually has happened. So I'm going to talk about a story of a landfill and the story how we took waste and how we put this waste fighting with the consequences of waste. So I'm going to take you to the landfill. So we are going to this landfill, which was relatively small, but still bad one. And I just noticed that my story is described here on the walls. So you say it's a problematic landfill. I say let's act. So we took some tools and we turned this landfill into a park, which is in active use right now. But this is not about, the story is not about park. We are in a climate conference, so this story is about climate. Landfill gas is a greenhouse gas. It contains methane. And if you collect it, then it is kind of a positive. If you do not collect it, it's a problem. In today's news feed, it was written that Dubai finally has decided to start collecting landfill gas. Fantastic. Many landfills globally do so. But such news, they nearly never tell what happened until today, or what will happen in landfills where they are either too small, like the reality is they are either too small or too weak in gas, or maybe the country or the community is too poor, or maybe there is no use for the gas. And this gas we still can't let go. And the problem is that there are so many landfills. In Europe we count 150 to 500,000 landfills. So we can't extract landfill gas in all of them, but they are leaking every single one. So I'm going to take you to the island of Saaremaa. It's in Estonia. We are here nearby the Baltic Sea. In our case, Baltic Sea very often is a driving force because it's very threatened and endangered water body. All those dots are landfills, old ones, not anymore in use. Right now we have 5 landfills in use. Instead of 350 municipal landfills, 5 is enough for the country. Maybe even that is too much. And I'm going to take you to the case study on the island. And island plays a role because sometimes life is different on island because resources are elsewhere and you have to transport them by boat. So, very short characteristics. We have a landfill, small one, but old one, in operation about 40 years or so. Nothing dangerous in here, municipal. And the main objective of this story and the case study is a landfill gas. Even though the landfill is small and the gas is not so huge problem as in probably in Dubai landfill, but it is there. So the decision made was that we have to take care of gas. Usually you collect it, but it's too big. So we had to reshape the idea of closing the landfill, and we decided to degrade this gas by using naturally occurring microorganisms, and we as engineers to support living conditions to these microorganisms. So in final decision it was that we should use a biocover to close the landfill. So what is a biocover? Biocover is a kind of a technology, a method to degrade methane. Very inexpensive and simple. You can use it in every country. And it is to fight with the residual or low methane emissions. Usually you take porous, organic rich material, and then methane that goes goes through or filters through this biocover, it degrades with the help of naturally occurring microorganisms. So methane disappears and we get rid of that. Which is the point? This technology is not unique. We know it is used here and there worldwide, and if you need to study more, then I give you a link. Go to the International Waste Working Group, target group, which deals exactly like that. But we have a different message here. We are on the island. Where do we take this material? So you can't take it from the waste facility because everything is quite small on the island. And then the idea came that what if we take it out from the same landfill? And if you take anything out from the same landfill, it is called landfill mining. It is exactly what we were discussing here during the previous presentation. Extract from the same landfill. The definition, of course, is longer. You can, by yourself, you can propose a good definition, but I recommend the last part of this definition is very, very important. So we should respect social and ecological criteria, because otherwise mining is just excavating, nothing else. So this also is not new. There is a consortium in Europe which is called Enhanced Landfill Mining Consortium, and we're the member of this consortium. So we know that very many scientists and also industries are actively hunting for a good motivation what to take from the landfills and how to take it. So to the case study. This is the easiest way how this kind of work looks like. You take waste out from the landfill, seal it into few fractions, minimum 2, maximum maybe 7, maybe more. We selected the simplest and we got 2 heaps. One heap is this what we want, and the other heap is, what is that? It is a plastic-rich material that is kind of interesting, because what if we can take something valuable out of it? So I stop here right now with a biocover and I jump into the fun part. So what can you do with a plastic-rich material? Of course, the easiest way would be to incinerate, to get energy, because this is what we do worldwide. And this is what we also tried. So we ended up in renting an incinerator. That is cool, because incinerators are not the ones that you can rent easily. But just because if you know how the incinerator thinks, you approach them. And in Estonia, the incinerator is big, so they can incinerate a big part of Estonian waste. But what if we make circular economy happening? Then they run out of fuel. So I knew that if I show this, they actually, in their heads, it is this sentence that is blinking. So we rented Tallinn incinerator for 1 day, and we incinerated only our excavated waste. Of course, we took the emission balance, we took the ash into the lab, both fly ash and bottom ash, and we studied also rare earth elements in our ash as probably the most expensive part. So it works. But incineration is kind of it is massive, big, and if you are happening to excavate in country where there are no incinerators, then it's no job. So you have to do more. And one of those more things is solid recovered fuel. It is similar but different. Solid recovered fuel is a fuel. You take waste, you turn it into the fuel which meets standards. So you have to do it in a way that it meets standards. So we took waste, shred it, tried to prepare as well as we could, and we delivered this material to the cement industry. Pretty cool. And they also wanted to see this as an additional waste feed because cement industry is very much energy intensive and unfriendly to carbon. So they use fossil fuels, but we replace fossil fuels. So we tried, it worked. But this too is kind of a little bit primitive because you are still burning. So the quality of this fuel depends on how big is the calorific value. And in our case, landfill in Estonia, in our region, is always wet. So we ended up in washing waste. So if you wash waste, it looks like, it sounds weird. When we developed the washing machine, 6 meters wide, 2 meters in diameter, I called to Electrolux because I know that they produce washing machines. And what do you think what Electrolux told me? Over the phone. Actually, we ended up in building the washing machine because they see opportunity. Isn't that cool? So by washing waste, our calorific value jumped 3 times and the moisture was near zero. The cement industry told us, now we like to take it all. But now I started to become jealous a little bit. They want it all, but maybe it is worth even more. So I took this waste into the other factory, which is producing building materials, plastic planks. We have an industry in Estonia which is specializing in producing plastic details from mixed plastic waste. This sentence in typical waste textbooks is impossible. You see it impossible, it's written there. So regardless of that, we did it. We took a certain amount of our waste into the plastic industry, even not washed. We turned it into agglomerates in a first step. In a second step, it went to the plastic, kind of typical plastic molding facility, and we produced building material like this. Isn't that beautiful? So this is material recycling, mechanical recycling, from the same landfill plastic. Nice. So if you need more, then I have 2 links. One is producing the planks still now, and the other is producing technology of factories. They're both actually running in full scale. Nice. What can you do more with such plastic-rich material? Of course, plastic is made from crude oil. Can we reverse it? So we took a handful of such material into the other lab of our neighboring university, Tallinn Technical University, the oil shale lab. And as soon as we opened the bag with raw material, I knew that they see opportunity. So very fast, we ran through the series of tests, and we ended up in having oil with such calorific value and with a very low sulfur. And the sulfur content was the reason why a ship engine company contacted us. How cool, so little sulfur. So this experiment was done, all those 4 were done for fun, without any funding, just to demonstrate that this is possible. Now we call it chemical recycling. Chemical recycling waste word seems to be big. What is our kind of understanding or knowledge is that surprisingly the yield of oil from the landfill or dirty old plastic is higher than from the new and fresh plastic. That is nice. So if you need more, then I also give the contact. Before going to the main point, what is in the plan? If you make such a landfill remediation project, you will have to describe it on paper. This picture comes from the project. After ending the project, it must look like this, But then almost incident happened when I was driving away from this landfill weekly meeting. A kilometer away, I had to crash stop my car because a person jumped to the road with skis. It was February, wintertime, ski. He was skiing on asphalt because so much he wanted to ski on a flat land like Ireland is. And then I turned around back to the landfill with a message. Hey guys, we are building a mountain. What if we turn it into the park? Very fast, we could find a contact landscape architect, because we teach landscape architects in our university. And she was living in the same city, and within 2 months, she drafted a project how to turn a landfill into a park. So nice. So today, instead of this ugly place, we have a nice green mountain with a ski tracks on top, with a disc golf, it's a green spot that is open for use. But the main objective of this presentation is still here to come. The main focus was that it has to degrade methane. So we were building a biocover, which is about 1.5 meter layer with a certain properties, and we covered all landfill with this. But the big question is it going to work? You have to monitor it. So we installed some monitoring wells, 3 such ladders, and now the PhD student is finalizing his thesis, doing regular studies and taking measurements about the gas. Does it work? It is a project that we followed 10 years. If I plot 10 years of data on one figure, then I get a lot of gas during first maybe 2 years. Then gas is described as red, and blue is little gas. Blue is positive, red is negative. So you see that red is disappearing, yellow is disappearing. So the landfill is stabilizing nicely, which is what we expect. But as a scientist, you always ask a question, is it some kind of a coincidence? Do you miss anything? The main focus is that landfill gas generated, if it stays in a landfill, it's okay. But if it escapes, then it's bad. So we need to study the surface area. So the easiest way to study something in a kind of ugly environment like a landfill is to pick a student. So we have made 11 theses on this landfill. And we can clearly show that a little bit of leaking, but actually not much at all. So landfill gas is generated, it tries to escape, it fails, there are maybe some spots, but the biggest positive information is that you still don't know until you make very clear. And the very clear means you have to know the DNA of stuff living in your biocover. So we took the other colleagues from Tartu University, we opened the landfill, the main measurement points, and we sampled who is living. And then we see that we have both. We have methane producers, because it's a landfill, methane is produced. And we have methane degraders, and those degrading ones, they are 1 magnitude bigger, which is nice. So you as an engineer, you have to make a living room for bacteria, and you have to select bacteria, not nature, because then we can call it technology. Some conclusions here. It was the project to do something positive for nature, degrade methane. And indeed, we see that we could degrade methane. So this kind of a landfill biocover is an option is a good alternative option in landfills with a very low methane generation phase or the end of active methane collection phase. So it works. What is nice is that the material that we took out from the same landfill, we could fit it into the frames that is necessary to degrade the methane. Yes, we have to adjust it a little bit, mix it a little bit, but now the material taken from the landfill is working for our benefit. And we do not use virgin resources. for covering the landfill. And this is, I can call, action where resources were, landfill resources were used for less methane. And all this, the rest of the story, how we played with the plastic-rich material, is actually a demonstration that technology is here, market is here. Okay, don't ask a question about the economy yet, because it's a demo project with a low budget, but we have demonstrated that it's possible. And also we gave a park back to the society. We had a case where journalists came to interview people, local people, and local people, they were not even aware of that they are in a landfill. They liked the park. And the journalist that came for 15 minutes stayed for 3 hours because that was so interesting place, so much wildlife back, so that he loved that. What next? Very scientific would be to repeat the same experiment in the same country or some other country, but it was the last landfill which was open from old times. So I can't repeat it in the exact same way, but I can repeat it in existing landfill. So we went to the existing landfill with a message: this all waste you can see is totally legal. And I think it should be illegal, because you can merely sense that methane is escaping. What if we put this method as a part of landfill management program, that you have to do so? So we built such a demo area and we ran it for several years. And the latest project is in Tallinn landfill. Right now, in November, we finished 2 cells. Tallinn landfill is a landfill where, old landfill, is the landfill where we collect methane. But now the methane amount is very low, and the aftercare period ends. So the question is, what next? How to manage this low quality methane which doesn't burn anymore? And the project was made and approved that we will replace this active methane collection with 6 cells like that. And during this year we build 2, during next year we will build 4. And I wish that every single landfill in the world are safe, so that we do a little bit, we give back to the nature by attracting bacteria into our biocover, which actually helps to degrade the methane and reduces the amount of methane in the atmosphere. So this was the case study, but no case study like this is a one-man band work. It's a teamwork. Even though if you don't read that, because it's small, you see that there is a lot of people who were active in this case. And the case teach me one thing: you become friends with the help of waste. Because the topic is intriguing, nice, challenging, and we see opportunity. And the most important, that other people tell it is not possible. But it is possible. So next time, maybe not next COP, but the one after, we should meet in a landfill, around the table like that. And I hope that that will come because of this presentation. Thank you. Any questions or comments? Then it's a time. We have some time to talk. If you have a kind of a smaller question, then I stay here and you can talk about this.
Thank you very much. I'm from Ghana. My name is Bashir. I work with the Ghana Shippers Authority. In terms of the opportunity, what are the opportunities to upscale this kind of project to produce results that the private sector person can invest in? Thank you.
This is a question we have discussed a lot in cost action. We had a cost action about landfill mining, and we published an article something like 500,000 theoretical scenarios, and we picked like 10 or so, and we understood that from all possible scenarios, because it all depends on the price of gate fee, for instance, the amount of waste, the type, climate, so many variabilities. About 8 to 10% of scenarios will give you positive revenue, or at least you come to the zero with price. So it's not very optimistic. But what I have learned from being opponent for a similar study in Sweden, the society accepts, and society means not only NIMBY and local people but also authorities, if this kind of landfill mining project becomes a remediation project. And I think that this is the key where we should really turn this key, because every landfill is something that awaits to be remediated, and you can do more. Just one example. This project was not meant to be like that. It was meant to be a typical regular, and there was a price tag. How much does it cost? And when we understood that we do not find cover layer, which is a clay, we got the opportunity to replace it with biocover, but we had no chance to replace the budget. So actually we did this work with a budget meant to cover this with clay, do nothing more, just bring clay, put back. So try to do more, not only cover it out of sight.
Hi, my name is Cynthia from Nigeria. For the biocover, what materials do you use? I know you said clay, but you had to switch to biocover.
Yeah, biocover is not clay. It should let gas out and water in. So it can't be clay. It has to be porous. And the typical, history-wise, the material was compost. But I hesitate a little bit, because compost we should use in agricultural land. So please come back tomorrow, because then it is our university's day, so we talk about soil. So we should not spend waste compost too easily. So I would recommend either compost that does not meet quality standards, or you create your own compost out of material that never becomes a quality compost, or you excavate from the landfill, or you use a combination of many. So there are kind of handbook full of hints what are the properties of this material. So if you want, I can put you in better contact. Yeah. You can do, we can do something against landfill gas. Out of curiosity, have you ever been in a landfill? Me, yes. So many. Usually I ask students, why did you go to the landfill? Maybe 20 years ago, I took waste to the landfill. It's wrong now. Now we go to excursion. It's a fun trip in many countries. So if you visit the landfill, you see the subject in a totally different way. That's why I recommend, instead, in order to make a decision about landfill future, you should go to the landfill and meet that. Then you don't panic that much. Landfill is consequences of our life. We should take responsibility. Thank you.